Hi everyone, in this video we'll go through algebra of derivative functions. That is, we'll find out what is a product rule, sum rule, difference rule, quotient rule and scalar multiple rule. Using these rules, we will solve few problems as well. Before we go ahead, we should remember all of these derivatives of basic functions. Algebra of derivative of functions. There are 5 rules here, right? One is sum rule, difference rule, product rule, quotient rule and scalar multiple rule. Basically, how do you find the derivative of functions when there are addition of functions, subtraction of functions, multiplication of functions, division of functions and scalar multiple of functions. Now, let's take this particular example. You have x square and log x. You can call this as one function, right? Let's call this as f of x. And this one we can call it as g of x. Function with respect to x. This is a function where x is there. This is another function where x is there. Now, how do I find the derivative? Nothing but I have to find derivative separately. Find the derivative of this function first, then find the derivative of this function and add both of them. That becomes the derivative of the entire function. Let y is equal to x square plus log x, right? We'll tell that this entire thing is y, right? Now we need to find dy by dx. That is, we have to find the derivative of y with respect to x. Now what do? We'll take derivative of x square first. That is, we'll take derivative of x square, then plus derivative of log x. What is derivative of x square? Derivative of x square is 2x. Using that formula, what is the derivative of x to the power n? Derivative of x to the power n is n into x to the power n minus 1. So here we have x square. So x square, n is 2. So 2 into x to the power 2 minus 1, which is 2x. So derivative is 2x. The simple way is you take the power. Here you have x square. You take the power, which is 2, put the power here, and then take this particular x, directly copy that x and reduce 1 from its power. Reduce 1 from its power. So 2 minus 1 is going to be 1, which is nothing but x itself, 2x. Now, plus, what is derivative of log x? It's 1 by x. So this is the derivative of this particular function. Now here there was addition. Similarly, you can have subtraction also. Instead of plus, you could have minus. So that's what we're telling here. D by dx of f of x minus g of x is d by dx of f of x minus d by dx of g of x. These are two separate functions. This is one function. This is one function. You find the derivatives separately. Now let's take the third one. Third one is what will happen when there are functions with multiplication. That is like this, f of x into g of x. Say for example, secant x into tan x. How do you find the derivative of secant x into tan x? This is into, right? So here you'll have to take first function into derivative of second function plus second function into derivative of first function. You can remember it like this or you can remember it like this. First function into derivative of second function plus second function into derivative of first function. Now let's take this particular example, secant x into tan x. So we'll assume y is equal to secant x into tan x. Therefore, dy by dx, right? We write the derivative as dy by dx. Dy by dx is equal to first function, right? Let's take this as f of x and this as g of x, right? First function and second function, or I'll say this is first function and this is second function. So I'll write dy by dx is equal to first function, which is secant x, into derivative of second function, derivative of second function, which is tan x, plus second function, which is tan x, into derivative of first function. What is first function? Secant x. So it's going to be dy by dx is equal to secant x into d by dx of tan x plus tan x into d by dx of secant x. So we'll just write secant x like this. What is derivative of tan x? It is secant square x. Then tan x. What is derivative of secant x? It is secant x into tan x. Now I'll take secant x as common. I'll get secant square x plus tan square x. So this is derivative of secant x into tan x. So remember one thing, whenever there is a multiplication, whenever there is multiplication of functions, you'll have to add. You'll have to add. Now we will go to the fourth rule. Derivative of a function when there is scalar multiple. Scalar multiple is nothing but a constant. you have a constant which is multiplied with some function. Constant multiplied with some function. For example, 2 sin x. 2 is a scalar. 2 is scalar. Sin x is function, right? Any number becomes scalar. So how do we find the derivative when you have such a case? You have to keep the scalar outside and find the derivative of only the function. That is, you assume that k is a scalar, right? You assume that this is k, right? And this is f of x. Sin x is f of x and 2 is k. So how do you find the derivative? Derivative is nothing but put this constant outside, that is here, put it outside and find the derivative of f of x. So for example, in this case, I'll put 2 outside and I'll say d by derivative of sin x, right? This is, what is derivative of sin x? It is cos x. So answer is 2 cos x. Now let's take the fifth case. Fifth case is, how do you find the derivative when there is division of functions like this? When you have division of functions, how do you find the derivative, right? This is called as the quotient rule. So what you will do, say you have this particular example, right? It's a division here, right? So in this case, you will have to take denominator function. So you assume that f of x is in the numerator and g of x is in the denominator. Take the denominator function, multiplied with derivative of numerator function, subtract. Always remember, it's minus sign over here. And then you take numerator function multiplied with derivative of denominator function and divide by denominator to the power 2, denominator square. Alternatively, you can remember like this, because f of x, g of x can get confusing. You can remember it like this. Denominator into derivative of numerator minus numerator into derivative of denominator by denominator square. In the product rule, you'll have addition. In quotient rule, you'll have subtraction. Let's take this particular example. Let y is equal to x plus 1 by x. Therefore, dy by dx will be, take denominator. Denominator is x. X into derivative of numerator. Numerator is x plus 1. Minus, now I take the numerator. What is numerator? X plus 1. Into derivative of denominator. What is denominator? X. By denominator square. That is by x square. Now this will be x into, what is derivative of x plus 1? Remember, here you have to put sum rule. You have to apply sum rule, right? That is, addition of functions are there. So you have to take derivative of x and derivative of 1. Derivative of x is 1 itself. Derivative of x is 1 and derivative of a constant is 0. Derivative of a constant is 0, right? So you get like this, minus x plus 1 into derivative of x is 1 by x square. We have applied the formula x to the power n is equal to n into x to the power n minus 1. So we have x here. There's nothing in the numerator, there's nothing in the power. So we assume it's 1. So n is equal to 1. 1 into x to the power 1 minus 1, which is 1 into x to the power 0. Anything to the power 0 is 1. So we'll get 1. So derivative of x is 1. So this will be x minus 1 by x square, which is minus 1 by x square. So this is the derivative of this particular function. X plus 1 by x is nothing but minus 1 by x square. Let's solve few problems related to differentiation using different rules. Quotient rule, product rule, addition rule, subtraction rule, and so on. The first one is differentiate root x plus 1 by root x the whole square. Now first, let's assume y is equal to root x plus 1 by root x the whole square. Now I'll have to first solve this, right? So this will be, if I multiply this entire thing 2 times, I'll get root x square plus 1 by root x the whole square plus 2 into root x into 1 by root x. This and this will get cancelled. So I'll get y is equal to root and square will get cancelled. X plus 1 by x plus 2. Now let me find dy by dx. dy by dx is, what is dy by dx of x? Basically you have to do like this, d by dx of x plus d by dx of 1 by x plus d by dx of 2. So what is derivative of x? It's 1, because you can assume that it is x to the power 1. So you apply this formula, x to the power 1 is equal to n into x to the power n minus 1, right? This is the formula. So this will be x to the power 1 is equal to 1 into x to the power 1 minus 1, which is 0. So it is 1 into 1. So x is 1 plus, what is d by dx of 1 by x? So derivative of 1 by x is minus 1 by x square. So you don't have to remember all of this. You can calculate, right? You can use the same formula. For 1 by x, I can write 1 by x. I can take x on top like this, right? Here you assume the power is 1. When I take it to the top, it will become x to the power minus 1. Here it is plus 1, it will become minus 1, right? Now I'll apply the same formula, right? X to the power minus 1. What is derivative of this? Minus 1. I'm using this formula. Minus 1 into x to the power. N is minus 1, minus 1. So this will be minus 1 into x to the power minus 2, right? So x to the power minus 2, I can get it down. So it will become x square. When I get it down, minus 2 will become plus 2. So this is x to the power minus 1, or 1 by x is minus 1 by x square. So either you can by heart this, or you can use the same formula, this formula, and get this. So this is minus 1 by x square. What is derivative of 2? It's a constant. Derivative of a constant is 0. So derivative of this function is 1 minus 1 by x square. Now let's take the second problem, where we have to find the derivative of log e to the power e. Now this is a constant, right? This is a constant actually. E is a constant, and to the power is also e, which means its power is also constant. So derivative of the constant is 0, right? D by dx of any constant is 0, which means d by dx of log e to the power e is equal to 0. So derivative of log e to the power e is 0. Now let's take this third problem, right? Here all the roots we will have to write in the form of powers, right? Let's first say y is equal to, I'll copy the entire thing, cube root of x square plus 4 by 4th root of x over 5 plus 1 by x7 plus x root of x. So we can write cube root of x square as, whenever you have something like this, you'll have to write it as, you have 3 here. So you make it as by 3. Put the power as 1 by 3. Similarly, here we'll write this as x to the power 5. This is 4th root, right? Make it as by 4. And here this is 1 by x to the power 7. Again, we'll leave this like this, right? You can also write this as x to the power half, 1 by 2, because this is square root. Square root is 2, so 1 by 2. So this is y. I can also write this as x to the power 2 by 3 plus, I can shift x on top. So it will become 4 into x to the power. Here it's plus 5 by 4. It will become minus 5 by 4. Plus here also I can shift x to the power, x to the top. So it will be x to the power minus 7. Plus 7 will become minus 7. Plus x into x to the power half, or root x. This is y. Now we'll find dy by dx. So what would be dy by dx here? X to the power n is equal to n into x to the power n minus 1. So simple trick is, just write the power as is, 2 by 3 into x to the power 1 less than the power, that is 2 by 3 minus 1, plus 4 into, again I'll use the same formula. I'll take the power is minus 5 by 4 into x to the power minus 5 by 4 minus 1, plus x to the power minus 7. So I'll take power minus 7 into x to the power minus 7 minus 1, plus, okay, here you can write, what is x into x to the power half? You can add the powers, right? You have the same base, theory of indices. When you have something like this, you can add the powers, right? You have x into x to the power half. You can write this as x to the power 1 into x to the power half, right? Nothing to the power means it's 1. I can add the powers when I have multiplication, right? And I have the same base, right? X here and x here. So I can write it as x to the power 1 plus half. I can add the powers. So I'll get 1 plus half is 3 by 2. So this becomes 3 by 2. This is nothing but x to the power 3 by 2. Now I'll write the power 3 by 2 into x to the power 3 by power minus 1. So this will be dy by dx 2 by 3 into 2 by 3 minus 1 is minus 1 by 3 plus 4 and 4 will get cancelled. So I'll get minus 5 into x to the power. This will be minus 5 by 4 minus 1 is equal to minus 9 by 4 minus 7 into x to the power. Minus 7 minus 1 is minus 8 plus 3 by 2 into x to the power half. So this is nothing but, so I have a negative power here. What I can do is I can push it down now. I can write as 1 by x to the power 1 by 3. When I bring this x down, minus negative power will become positive. So it will become plus 1 by 3. This is minus 5. Again, there is a negative power. So let me get this x down. And negative power will become positive power. Minus 9 by 4 will become plus 9 by 4. Minus 7, I'll get x down here. Minus 8 will become plus 8. Plus 3 by 2. x to the power half, right? X to the power half is nothing but root x. So this is the derivative of this function. Instead of x to the power half, I can write it as root x, or I can leave it as is. Let's solve this fourth problem. Here there is multiplication of functions, right? This is one function, this is one function, it's multiplication. So we'll have to use product rule. We'll have to use product rule. What does product rule say? First, let's write this. Y is equal to 5x square plus 3x minus 1 into x minus 1. This is like f of x and this is like g of x, right? So we'll find dy by dx. I'll take first function. 5x square plus 3x minus 1 into derivative of second function. Basically, I'll use this formula. For product rule, it will be first function into derivative of second function plus second function into derivative of first function. So I've taken the first function here, derivative of second function, which is x minus 1 plus, now I'll take second function, x minus 1 into derivative of first function. What is first function? This one, 5x square plus 3x minus 1. So basically I'm calling this as first function and this is second function. So what do I get? I get 5x square plus 3x minus 1 into derivative of x minus 1 is nothing but derivative of x is 1 and derivative of 1 is 0. I'll get 1 minus 0 because derivative of constant, derivative of 1 is 0 plus derivative of plus x minus 1 into derivative of this entire thing. You'll have to use the sum rule here, right? You have to find the derivative of this and this separately. So derivative of 5x square is, I leave the 5 as is. So it will be take the power 2 into x to the power 2 minus 1 plus 3x, nothing but 1. Derivative of x is 1. Derivative of minus 1 is 0. Right? So I'll get dy by dx is equal to 5x square plus 3x minus 1 into 1 plus x minus 1 into 10x plus 3. So let's multiply this. Dy by dx is equal to 5x square plus 3x minus 1 plus, I'll multiply this. So I'll get 10x square minus 10x plus 3x minus 3. This is nothing but plus 10x square minus 7x minus 3. 5x square plus 10x square is 15x square. 3x minus 7x is minus 4x. Minus 1 minus 3 is minus 4. So dy by dx is 15x square minus 4x minus 4. We will cover some more problems in the next video. If you have found this video useful, do press a like and share it. Thank you.